And f of z equals z plus 3 upon z into z square minus z minus 2 in powers of z in the regions modulus of z less than 1, 1 less than modulus of z less than 2 and modulus of z greater than 2. Here z square minus z minus 2 can be factored as z plus 1 into z minus 2 and hence f of z can be written in partial fractions as a by z plus b by z minus 2 plus c by z plus 1. When you multiply both sides in the numerators with z into z plus 1 into z minus 2, we obtain this equation. In this equation, when you give z equals 2, you notice that these two terms become 0 and we get 6b equals 5, which gives b equals 5 by 6. In this equation, when you give z equals negative 1, you see that this term and this term become 0 and we have 3c equals 2, which gives the value of c as 2 by 3. In the same equation, when you give z equals 0, these two terms become 0 and we get negative 2a equals 3, which gives a equals negative 3 by 2. Now we substitute all these values here and we get the new format of f of z given by this equation. In the first region, modulus of z less than 1, when you divide both sides of this inequality by 2, you get modulus of z by 2 less than 1 by 2, which is less than 1. Therefore, this factor z minus 2 when rewritten as minus 2 times 1 minus z by 2, and when 1 minus z by 2 is taken to numerator, it becomes 1 minus z by 2 the whole raised to negative 1, which can be expanded using the identity 1 minus x the whole raised to negative 1 equals 1 plus x square plus x cube plus etc. whenever modulus of x less than 1. Here, modulus of z by 2 is less than 1 holds true and hence this can be expanded in this format. 6 into negative 2 becomes negative 5 by 12. 5 is written as it is. 6 into negative 2 becomes negative 12 in the denominator. We have 1 plus z when taken to numerator becomes 1 plus z the whole raised to negative 1, which can be expanded using the identity 1 plus x the whole raised to negative 1 equals 1 minus x plus x square minus x cube plus etc. whenever modulus of x less than 1. Here, modulus of z less than 1 holds true in the given region. Therefore, this can be expanded in this format. Now we have expanded f of z as powers of z in the given region, modulus of z less than 1, which is the required power series or the Laurent series expansion. In the second region, 1 less than modulus of z less than 2, we have from modulus of z less than 2, modulus of z by 2 less than 1, and from the inequality, modulus of z greater than 1, when you take reciprocal, this inequality is reversed from greater than to less than, and we have 1 by z whose modulus is less than 1. Now we rewrite z minus 2 as minus 2 times 1 minus z by 2 and we get this term. We have z plus 1 rewritten as z times 1 plus 1 by z, so that 1 minus z by 2 when taken to numerator becomes 1 minus z by 2 the whole raised to negative 1, which can be expanded in this format because modulus of z by 2 is less than 1 holds true in the given region. And we have 1 plus 1 by z the whole raised to negative 1 can be expanded as 1 minus 1 by z plus 1 by z square minus 1 by z cube plus etc. because 1 by z whose modulus is less than 1 holds true in the given region. Thus, we have expanded f of z as powers of z in the given region 1 less than modulus of z less than 2, which is the required Laurent series expansion. In the third region, modulus of z greater than 2, we have f of z which can be rewritten as this equation. Here, what we have done is z minus 2 is rewritten as z times 1 minus 2 by z, because from the inequality modulus of z greater than 2, we obtain modulus of 1 by z less than 1 by 2, which is less than 1, which is obtained by taking reciprocal of this inequality. And when you multiply this inequality in the numerator using 2, we have modulus of 2 by z less than 1, because modulus of 2 by z less than 2 by 2, which is 1. Therefore, since modulus of 2 by z less than 1 holds in the given region, we will rewrite z minus 2 as z into 1 minus 2 by z, which when taken to numerator becomes 1 minus 2 by z the whole raised to negative 1, and we can expand it using the identity 1 minus x the whole raised to negative 1 equals 1 plus x square plus x cube plus etc. Since modulus of x less than 1 holds true here. Similarly, since modulus of 1 by z less than 1 holds in this region, we can rewrite z plus 1 as z into 1 plus 1 by z. As in the previous case, we take this to numerator and we get the same term which has this same expansion. Thus, in the third region, modulus of z greater than 2, we get this Laurent series expansion for f of z